Alright, so this little experiment here will only give you a 1/4 inch of volume in that tub, but we need like 8 inches, and I figured up that we would need 675 cubic inches of volume. If now you'd think, and all of my research says that just doubling the volume of the pressure hose should double the volume of the water, but it doesn't. So what I did, I went and got me a piece of PVC, and it's not near 600 and something. But what I'm going to do, and I got 3 caps, and we got three caps, and the reason I got 3 caps is because if that overdoes it, if this overdoes it, then I can calculate how much it overdid it, saw part of this off, and then do this. But what we need to do is get our machine over there and get it set up so that we can try this experiment one more time. Now this is only an experiment, because if you think about it, I mean, I know it aggravates people, but when you the engineers have figured out that's how much water the least amount of water it's going to take to get your clothes clean. And this isn't what I want. And anyway, it drives people crazy to have these HE machines, these high efficiency machines, and they'll look in there, and the clothes don't even have water going over the top of them, but they're wet and they're agitating. And the bottom line is, if your clothes come out clean, don't worry about it. And I've seen all kinds of hacks that people have been using on these machines to get that water level. Either they pour more water in it. I went to one lady's house, and her husband had fixed up a T configuration on the cold water line where she could turn a ball valve on with a little piece of hose that he had cut the connection off. Like that, he just cut one end off, and he had a T connection in the hose, and she would just turn the ball valve on and fill her tub up as much as she wanted. So I guess that worked for her. Yeah, she just fill it like that. Other people just pour water in, a bucket of water in, or whatever, it just aggravates them. They don't think their clothes are going to get clean that way. But what we're going to do is we're going to take this piece of pipe just to see if we can get this thing to work the way. See if we can hack it. Is what we're doing. I need a drill for this. I'm not a fan of re-engineering things, because you got to consider. So once you get the volume of this water up where you want it, are there other components of this machine did you take into consideration that the suspension rods and springs may not hold that weight of water? That's what I would be concerned with. So if you add 8 inches of water See, this machine goes to this level right here, and if you wanted it to go up to here, that is a lot of water. And water weighs, I forget how many pounds per gallon, 8 point something, I don't know. I mean, as an aircraft pilot, I'm supposed to know all that stuff. I know the weight of fuel, but I should know the weight of water too. Anyway, we will make this cap right here. We'll put these two barbed connectors in here. Let me see where I want to put them. Equidistant. And I want to hang on to that cap so it doesn't come up. When it goes through, it wants to jump. Why is that? And when it jumps, it goes sideways. Yeah, it'll work. So let's put these in there. Put them in there really tight. And on the other side of them, I will put some PVC glue. And this is the last attempt I'm going to make, because my math says it needs 600 and something cubic inches of volume, and that would take like a 7-foot 3-inch pipe. I'm not going to do that. Get some PVC glue right here. And I'm going to run it around the inside of those threads. That should make it airtight. And now I'll glue this to that. Just like so. Now I'll glue one of these on the other side. Just like so, and that should be airtight. Now, what we'll do is take one of these, put like that. And let's take the back side off of this. Zip that right there. Yeah, this is called re-engineering. Usually doesn't work. I just want to see if the volume of the air makes it come up any further. So we've got it 2 1/4 inches with that. Well, it comes up 2 inches without a modification. Our first modification brought it up 1/4 inch. And the second modification is a whole lot more volume. A whole lot more volume. So let's see how much we can change it. And you know I'm going to have something to hold this. I'll just zip tie it right there. That's holding right there. I'll just get a zip tie lightly. Hold the edge of it there. Might need two. I think just one. Yeah, okay. It's alright. Now, let's give it a shot. Let's put some water in it. What do y'all think? Down in the comments. I think the better solution would be the electronic solution. It would be better if you could get a potentiometer that you could adjust from a knob up here. I'm also thinking that maybe some of these machines that do fill with deep water, if you change this switch right here, I'm wondering if that switch might be a potentiometer in itself, and if you change that switch with a different voltage, what do you call, variation, that you might be able to manipulate that. That's the next thing. But you know, I have thrown more of these switches away because they never go out, and I don't have any spare ones. I'd try that. That'd be the next thing I'm gonna try. Change the switch, because that switch might be a potentiometer. Alright, we know that using this, the water level comes up to the 2-inch mark just with the regular hose on it. It comes up to 2 1/4 inch mark with this on it, and we're going to see how much it comes up with that mark on it. Well, the wind was blowing in here the other day and knocked that down. Scared me to death. Bam! What the heck? Let me put one of these in there so I can observe. Let's see. We got it on deep water. One rinse, warm, heavy. Start. Did I turn the water on? No, I didn't. There we go. See, the method of this machine is, as it, see, it's turning, it's wetting all the clothes. And they say it does that so it can weigh the clothes. Well, there's no strain gauge on this thing that weighs the clothes, so it must be doing it by torque or whatever. So if it wets the clothes down, then it will I'm trying to figure out how that actually works. If it's wetting the clothes down before it actually goes to fill, how does it determine how much water to put in? I'm not sure. But it does know. So there it went one full cycle in the round, so it got the clothes pretty wet. And now I think it's going to fill. It looks like we're passing the 2-inch mark now. And that next row of holes should be the 3-inch mark. So we've got it at least an inch over. We're approaching the 4-inch mark. Now that would probably be sufficient right there. That's the 4-inch mark. So we got up to 5 inches. Now that's sufficient right there. Alright, let's pause it. I think that would be sufficient water. Because if you add your clothes also, let's let that settle down and we'll see how many more inches it was. See, I was hoping to get to here. Okay, is that settled? Alright, that's 5 1/8. So we went from here to 5 1/8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and a half. 11 1/2 quarters. So we can do the math and figure out the volume of that. And did we increase it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did we increase it 11 1/2 times? Is the internal volume of that 11 1/2 times that? It looks like it might be. So, using something like this, what you could do is probably go to 4 inches, about the same distance, and defeat that. So actually that's going to work. But I would say a 4-inch pipe, and you don't need schedule 40. That's all I have. So a 4-inch pipe, you could probably bring it up to 8 inches. That right there would probably satisfy most women. And that 8 inches right there. And their laundry would get clean. So they actually need to 1, 2, 3, 4, 5, 7, 8, 9, 10. We need about 10 more quarters. One, 2, 3, 4. So we roughly need to double the volume of that pipe. Double the volume of that. But you don't want it much longer than that. You'll need to devise a method to hang it on the back side. But that's how you can defeat the water level on this thing. I'm not going to do it anymore, and this is the end of that experiment. So we've proven that you can increase the volume of the water by must have an air leak too. Yeah, have an air leak on that because it's still filling up. Anyway, we've proven that we can engineer this thing in by increasing the air volume on it. Anyway, thanks for watching. Give me a thumbs up if you like the video, and subscribe. Keep it up.